and thanks for joining the Pragmatic Works webinar this morning. I know everyone's busy, so I appreciate everyone's time out of their busy day to attend, and also happy Tuesday. So today's topic, we're going to talk about the Azure DevOps, and it's something new to me. I've only picked it up recently, but I'm really excited about it, and I feel like it's a great addition to the the arsenal of skill sets that we have. So with that said, a little bit about me. I work at Pragmatic Works as a lead consultant. I do Azure Architect. I've been working with computers for a while, and I started off as an anthropology degree, and I got into banking, and then found my way into IT. So that's how I ended up in computers. So today's agenda, why do we even want Azure DevOps? We're going to talk about continuous deployment, CI/CD, and then we're going to talk about the Azure DevOps services, the repos and the pipelines, and then the infrastructure as code, and then we'll do a quick demo. So what problem are we trying to solve is the first thing. So, starting off in computers, early 90s or so, we had the client server. The internet hadn't been introduced yet. So basically, we had a variety of problems to solve, and one of them was source code repository is a key one, and another one is deployment options. And as you can imagine, back then, trying to stand up a SQL server, it was a lengthy process, for example, or having the sysadmin go out and requisition the server, waiting for the server to be delivered, adding the memory, the hard drive, installing the operating system, all the updates, the patches. It was a quite lengthy process. Now we have the benefit of the Azure, where we could stand these things up pretty quick, and we can also store code pretty easily. In the world of Agile, the clients are looking for quick wins. So quick wins over time is pretty powerful, and they also want to be included in the flow of the projects. So what that means is transparency, and also being included as the project progresses. Another key thing I'd like to mention is that programming is a team sport. So gone are the days where we have a client server dev or a mainframe dev that is responsible for the code, the database, the reporting, moving the code, the business logic. They're the expert, domain experts. Programming has been segmented quite a bit, and it's now a team sport. Another thing is we want to deliver quality quickly and use the best practices. DevOps integrates tightly with data governance, and data governance is another key component of the life cycle of any project, including data projects, for good reason. It applies structure, which is well needed in the world of programming. Another one is we can leverage the Azure DevOps. Specifically, what I'm going to talk about today is the source code management and the deployment options. There are other features, but that's what I was going to focus on today. So with Azure DevOps, we're talking about an end-to-end solution. So that means from soup to nuts. So how do you design your system? How do you build it? How do you move the code from dev to test to production? It's all involved. So we have to plan with any project is how we manage the work. We develop the code through continuous integration, the CI, and we deliver through constant delivery. And then we operate. So we have monitoring, alerts, compliance. It's a full life cycle. It encompasses everything. It's all self-contained within the Azure DevOps life cycle, which is cloud-based, which is a nice feature. Obviously, for a variety of reasons, it's remote and all that. So this is an actual quote that I lifted off the website, and basically, DevOps culture breaks down the siloed disciplines and unifies the people, the processes, and the technology. And that's key to any project in technology. It's not just a coder just sits down and writes code, and then they log off and they're done. They have to think about the big picture, and that's definitely changed over the years. And DevOps allows us to do that quite nicely. So when we talk about continuous deployment, integration, and delivery, it's really two buckets. And one of the buckets is basically the repository. How are we going to store this code off so that we have changes over time, that we can allow each developer to work at the same time and work on different features, which is that's a requirement. Teams can grow over time and people change over time, developers' roles and responsibilities. So having that all tracked through an online repository is key. And then as each developer completes their code and it's tested, unit tested, we can then merge their changes back into the root branch. And then based on that pull request, is what they call it, we can trigger a deployment. So it's pretty tight integration, so we can go into that in more detail. With continuous delivery, there's really two components under that bucket. And basically, as we talked about earlier, provisioning a SQL server, for example, is, buying the server, standing it up, loading the database, all that. So we have the ability now to automate the Azure infrastructure, and not just database. So basically, any component within the Azure ecosystem can be automated through continuous delivery, which is really incredible. Once I saw this, I was like, man, this is the way to go. The other component within the continuous delivery is, for example, the code base. Obviously, coders are writing code. It gets stored to Git. That code has to be tested and it has to be moved to test for quality assurance, for example, and then have the business users test it and find the bugs and reiterate process so that we get out all the bugs. But it makes it a lot easier to move that code from environment to environment to environment, and we'll go into that in more detail. So some of the advantages is automated. It can be automated. You're not required to automate everything, but the framework is in place to allow easy automation. The code is deployable. I know I worked at one job where we had like 15 people attached to a project, and it had to be deployed in a specific order. And the way that we did it was we had an email chain with everybody on the email, and the first person that was responsible did their change. They would email the group and say, all right, I'm done, step 2, step 3. And this went on for 15 steps. And that's the old-fashioned way of doing it. This is a lot easier. Another key component is that developers are more productive because they're not weighed down by the administrative tasks that typically we had to overcome in the past. Another thing is the agile methodology. There are small and frequent changes. So the key is to plan out your chunk of work, complete the work, test it, and then push it back into the root and deploy it. So we kind of get rid of a lot of the bugs, so we speed up the development time, and it's a very stable system. And lastly, the stakeholders, the people who are sponsoring the project, are integrated into the life cycle of the project, which is key because they're funding it and they want quality fast. So we touch on this briefly, but basically the term is called infrastructure as code. So if I want to stand up a SQL server, it's pretty easy to do it in Azure. It's a couple clicks and you're on your way, and it provisions it, and after a few minutes you're up and running and you can just start coding. Typically, to do this in years past, it was quite cumbersome. There were a lot of hurdles and such, but this really streamlines it. So that's it's a repeatable process. So let's say you stand up a SQL server, you can actually use an ARM template in a Visual Studio project and you deploy it, but then you can take that exact same code because it's parameterized and deploy it to another environment really quick, and you can automate that as well. So it's repeatable, it's reliable, and it integrates with the data governance. So it's fully governed. And we talked about automating things through ARM templates. An ARM template is basically a JSON file, and the JSON file can be created. It's kind of cumbersome. It's very syntax oriented, so you probably don't want to create your ARM templates from scratch. You probably want to log on to the Azure and have them start the ARM template for you. But then you put it in the Visual Studio project, and then you save it to Git, and then you can deploy those resources using something called a release pipeline, which automates. It can be automated. There's triggers possibly if that's the way you decide to go. There's also a feature for testing, and there's also a gateway. So let's say you're authorized to move from dev to test and possibly UAT, but you're not allowed to move it to production until somebody approves it. And that approver can be designated with an email. So they'll have an email appear in their inbox and say, oh, looks like the development team is ready to deploy this code to production. Let me verify that all the I's are dotted and the T's are crossed. And we talked about the data governance, but I would say that's another key component that has really, come a long way for the programmers in the regard that it wraps a framework around the entire process. And not all companies are leveraging the benefits of the data governance, but I've worked on a few projects and I would say it's completely beneficial. And the key components, the three pillars, are the board of governors, the data stewards, and the data custodians. So it's kind of a pyramid shape, and the board of governors sit at the top, and they're responsible for meeting periodically. It's typically either assigned role, like an executive vice president, or some senior person of each department, such as HR, sales, what have you. And they sit on the board, and they're responsible for making the data an asset for the organization, so you can leverage it to increase sales, reduce cost, and streamline your processes. So the board of governors meets periodically. They make decisions on certain aspects regarding how they're going to treat the data, handle the data, make sure the security. Beneath that, we have the data stewards, who are typically a person assigned that's an interim between the BI team, developers, and the business. And typically, they're domain experts, so they probably know the business better than anyone. And not necessarily the entire organization, but specifically to maybe a portion of the sales or what have you. So you could have a series of data stewards that roll up to the board of governors. And beneath that, we have the data custodians, who are basically anyone who touches the data along the trail, such as the programmer, the architect, the DBA, network security, administrators, and such. So that's the basic framework for the data governance, and the DevOps plays a key component. So that's the people aspect, and then we have the processes. So how do we move our code from dev to QA? Well, we used to it was a free-for-all. So now we have a legitimate process that is, governed, it's auditable, it's documented, and it removes a lot of the what ifs, and it makes it a lot better. And obviously the technology, we're leveraging the Azure DevOps. So when we think of DevOps in Azure, this is the main thing. So we have boards, which are basically allow you to manage your sprints and plan sprint planning, and you can assign tickets, and the tickets get assigned to resources, and those resources can be tracked over time. You enter your comments, and then that's how that works. And then we have the repos, which are the source code repositories. I started off early in my career. One of my first jobs as the Visual Source Safe Administrator, and that was a great tool back then. It was client side. There wasn't a web, but basically I was responsible for administering, such as adding and subtracting users. We typically didn't give destroy rights, but people had delete rights. So you could delete something, but somebody would say, oh, I deleted this, but I need to restore it. So I had to do the restores, and that was the early days of the source code repository. And there's a lot of stories around that. It's people checking stuff out. I thought it was a good product, but anyway, this is the current version, the repos in Azure DevOps in the cloud. The pipelines are used for deploying your code, and they can be automated, and there's audit trails. We can also have test plans built into our DevOps deployments. So after the developer writes the code, it gets saved to Git. We create the service, the release pipeline. We can actually embed test plans within the pipeline to ensure that there's no gotchas. Like maybe there's some extra characters that are causing the JSON to not compile correctly. And then lastly, the artifacts. It's just some third-party stuff to allow continuous development. I haven't messed with that one too much. So this is what it looks like in Azure. There's your repos, and you can see the other items, and it's basically whatever you click on, it opens up to that branch, and then you can select what you want. And then you can see that we have in more detail, and then on the right of that, you can see that's a Git, their deployment group. And we'll go into that in more detail. But looking at that last screen, the files, the commits, the pushes, the branches, the tags, and the pull requests, the files are basically all your source code. And that's where your source code lives, and anything gets added or deleted or modified, you can see the changes over time. When people commit their work, that means basically that their code is, hopefully it compiles, and that. So what that means is, if we have 3 developers on the team, each of us has our own branch. So we create a separate branch, let's say development, and then we have like a feature perhaps, and then the feature, we could spawn that off into 3 branches. And as each of the 3 developers complete their work, they commit it, it gets bundled into the next layer. So from development to features, the features branch is now the live branch, and that's what will get deployed to the test environment perhaps. And you do that using a pull request, which is at the bottom here. So a pull request basically says, take my code and push it into the next layer up. And that's how that works. And you can trigger stuff based off of those pull requests. And so that's how that works. We can also tag, like anything in Azure, we can tag stuff. It's like comments and stuff. So you can easily manage your Azure infrastructure. And we kind of talked about branches earlier. So within the repos, there was something called TFS a long time ago, or it's still around, but they renamed it to Azure DevOps Server. So that's one flavor. And then another flavor is called Git, G-I-T, and that's the one I use the most. And I like it because it integrates tightly with the data factory. There's an easy way to configure it so that you can keep your objects stored in the Git repo. And another feature is the Azure Databricks. It also has another easy to connect feature to the Git. So the Git creates a commit with every push. And then you have your pull request to merge the code. And then you can apply a trigger. So once that root folder perhaps gets, pull request on that root folder, you can apply a trigger that's going to execute in the cloud, and it's going to deploy your code. And what I like about the Git is there's a lot of nice samples here out on GitHub. So let's say you're doing storage accounts and you've never done that before, so you want to see some examples. So you can go to this website and you can see other people have committed their projects, and you can peruse those and look at how they did it. I find it a good feature. Some of the benefits of using Git: simultaneous development for small or large teams, faster releases, built-in integration. It integrates tightly with the Visual Studio. There's strong community support. The Git works, with your team. And then we have the pull request, and you can apply branch policies, and the policies can lock it down however you see fit. Another topic is the pipelines, which is beneath the repos. And the pipeline is basically your deployment. And under deployment, we have infrastructure as code deployment, and then we have our code base as deployment. So there's different features, including the pipelines, the environments, the releases, the library, task groups, and the deployment groups. And the pipelines could be used. So basically, you create a pipeline, you add your widgets, and then you can deploy it, and you can have triggers. The environments allow you to manage your deployments. Releases is a good one that I use quite a bit to automate the deployments. The libraries, variables, so you can push to different environments based on variable selection. Task groups, you standardize and centralize, manage common build and deployments. And then your deployment group allows logical group of target machines. And when we talk about releases, we could deploy the code base using the cloud-based utility. It's basically an online website, part of the DevOps, where you can build your pipelines and then run them and execute. You can edit them, and all your changes are tracked over time. And some of the features that I've been using lately are the ARM templates, the DAC plaques, and there's literally hundreds of extensions to choose from. So, if I had a lot of time, I would go through and peruse some of the extensions. But if you have a chance, go out there and take a look at some of those extensions. It's quite powerful. I mean, there's really a lot you can do. So it's repeatable, automated. There's an audit trail. You can embed approvers gateway, so it can't push unless somebody approves it, and then those emails get sent out. And lastly, there's something called a demo generator, which I'll show shortly, but essentially it allows you to look at examples of fully baked projects in Git that you can deploy and execute in your environment, and it's kind of cool. So for now, we'll go ahead and talk about some of the demo stuff. So what we have here is SSMS, SQL Server Management Studio, which probably some of you are familiar with. And this is a database project. So essentially what we did was we created a new project. We clicked on SQL Server, we specify some information, and then what you can do is you can do a right click on this and you can import a database. So you can just connect to a database, it'll ingest all the objects. And then over time, you can do schema compares and you can compare it against prod versus test versus development. So that's a good feature. But in this case, we have a few objects already created. And if we were to look at, this is not this is Visual Studio. Okay, so SSMS is here. Sorry about that. This is your Management Studio, and you can see that the database has already been stood up to server, and we can confirm that using our Azure portal. And the portal says that, oh, we have this resource group. It's basically a collection of resources in a bundle, and we call it resource groups. And then basically it can contain multiple resources. And then in this case, we have our server stood up and we have our database. In that case, we can scroll back over here, and if we open up the tables, we'll probably see no tables. So this is the project, and then we click on over to Team Explorer, and we can do changes. If there were any changes, which there are, we could save those, and it would initiate. Okay, so then we'll jump over to the Azure. And we'll jump over to the pipelines. And in this case, we'll jump over to the release pipeline. And you'll see that we already have a release created for that particular project. And if we were to open this and go to our latest release, you can see the last one succeeded. But essentially, if we were to edit this, just to show you, the components how easy it is to create this, what you do is you click on your artifacts, and then you can point to your Git repository, and we select the branch. So that's one aspect. And then we have these things called stages. And in this stage, you can name it, and then you open it up. And this is the meat and potatoes of the project. So basically, we name our DAC pack. We have an agent job, and the agent job is basically a server. On the Microsoft site, there's a pool of servers, and those servers are, sitting around waiting to be leveraged. So once you execute the thing, the next available server becomes available, and it uses that. It's kind of like a borrowing. And then once it's done, it just goes back into the pool. And then we have this thing called the build, so we can build our solution. And then in this case, I'm using the DAC pack as the source code base. So with that said, we can go back to our Visual Studio, and I'm just going to remove this file is not necessary. And then anyway, we can go ahead and deploy that. Let's go ahead and deploy that script. So we'll go ahead and create a release, say create, and then we'll go to our 16, which is the next one, and you can see that it's queued up, ready to go. So what's going to happen, we hope, is that it's going to run, it's going to execute those 3 tasks that we just showed you, and then basically we should have objects in our SQL Server. And that's one way to deploy the code using the release pipeline. So it's just going to take a minute here. Obviously, if it's a larger database, it'll take longer, but we'll just let it finish out. And if we get a green success, we'll jump over to the SQL Server, and we should have objects. I was really surprised at how easy it is to use this. And once you start playing around with it, you kind of get a feel for some of the gotchas and the tricks. Another feature is sometimes these things don't work on the first try or the 50th try. So you keep trying, and then there's good troubleshooting techniques to there's a lot of logs and stuff, and it shows you every step of the way where the error was and what succeeded, and it kind of gives you a running history in real time, but then it's also saved so you can go back in time and then look at it. And like I said, as you start building more of these releases, you get into a pattern, and it starts to flow pretty nice. So this Azure is based on the SQL DAC pack, and it's basically reading from here. There's a DAC pack. So when you process the project, the DAC pack gets created, gets stored in the Git, and then it gets deployed. So another thing to mention here is on the artifacts, there's the ability to set a trigger. And once you set that trigger, you can say, okay, if the root master folder is modified, let's kick off the process. So that's kind of cool. And hopefully if this finishes, then I can show you that as well. So this would be a code-based release. You can also stand up the infrastructure. So for example, this here would be a key vault, and this key vault we can stand up using code. And the code is based on these things called ARM templates. And in the majority of ARM templates, we typically have something called the deploy, and these could be named anything, but that's what they are named out of the box. And your ARM templates have parameters, and you could specify the parameters. And here you say this is a string, this is an array, a Boolean. So that's basically the code that's going to stand up your key vault. And then there's some more code here. Now I didn't write all this. It's basically out of the box when you go into Azure, and you can select it. And then what happens is it's a 1-for-1. So in this case, we have a name, a location, a SKU, and here we have a name, a location, and the SKU. So in this case, we hard coded the value of what we want these to be. Now keep in mind, we can, the powerful thing behind this is that we could create another Azure deploy for our test environment, and we could create one for our production environment. And then when you deploy the thing, you just tell it to use a different parameter file. So you would have a Azure deploy test, dev, and prod, and then depending on which one you selected, you could push to different environments. And they don't have to be hard coded. They can be read from the key vault or what have you. So it's really dynamic, it's flexible. So it succeeded. It only took a little while. So we're back in our Management Studio. We'll go ahead and refresh. And there's no tables. Okay, so for whatever reason, that's good. So anyway, okay, so it created a second one, I believe. Yeah, so there it is. My bad, I was already connected to the wrong database. So that happens in programming. So also demos. So here you can see that it's a 1-for-1. So you have these tables here, these tables here. If we go back to our project, you'll see that those same tables are there. So in this case, I'd like to go ahead and add something. I'll just add a table, and the table, we'll call it demo test 1. And then we'll just say add. It should create a new script, and it created this script right here, and I'll go ahead and save it, and then I'll go ahead and build the solution. And then this may take a minute, but it's going to generate the DAC pack, which is here. So it looks like it finished. So I'll go ahead and click save. And then what we'll do is we'll go back to our Team Explorer, which is connected to Git. And the way you do that is you go into connections, manage connections, and you can connect to a project. And the project, it'll log us into Azure. And then it'll give us our available projects to choose from, and you can select it. But in this case, I'm already connected. So what I like to do is you click on changes, so that'll identify the changes, and I don't think we need this file. We'll just leave it. But you can see the DAC pack is encompassed within the project. Some people do that, some don't, but in this case I did for the demo. And you can see that it added the new script, and I think we're in good shape, so we'll just put some changes, added table. And then when you commit your changes back, it's gonna save it up into the Azure DevOps repo, and I'm gonna do a push at the same time. So basically you can save it there, but if you don't do the push, okay, we got an error. So anyway, oh, that file here, it says permission denied on the DBML. So what that means is that we just have to open this, go to our folder solution, which is over here. And it created these files. Now, typically you would have a file in there to exclude certain files, but I didn't do that for the sake of the demo. But I'm going to go ahead and delete both of those, and then we'll just open up the project again. And those files should be gone, and we should be able to deploy our code back to Git. So we'll go ahead and wait for that to open. All right, so you'll see the plus here. That means it's a new file. These other ones have locks on it, so they're already there. If we go back to our Teams Explorer, we'll go ahead and click on changes to identify the changes that just occurred. And you can see the changes are there. And we could say added table, commit all, and then push. And that time, you'll see the outgoing push, and then all of a sudden this will disappear. Yep, and then if we jump on over to here in our releases, hey, look at that. The thing kicked off automatically. It's queued. How'd that happen? Well, there's a trigger within this thing, and we set it to trigger on change. So when the Git repo changes, and you can see here we have the Git, and then I believe it's under this one. You can see how we're storing off the DAC pack within the project. So once it identifies a change to this repo, it automatically kicks off the process. So we'll just let that run in the background because it might take a minute or two. So back to our key vault. We can stand up the key vault as an infrastructure as code, and you can see that we're setting our settings here, and then it references these GUIDs, which are, your tenant, which are part of the Azure subscription. And another way you could look at that is if we went into our key vault, and a key vault is basically it's basically like a repo, a mini repo, in that you can store off keys, secrets, and certificates. And if we were to look at the secret, for example, I've saved a few different times, so it keeps the different versioning, which is nice. And then from there, we can show the secret value here, and they could copy that. But essentially, I'm just showing you that there's a value in a secret in a key vault. And the key vault could be stood up using Visual Studio, infrastructure as code, and that's what we would do if we wanted to execute this the same way. We have another release pipeline for this one, I believe, and it's called IAC, infrastructure as code. And if we were to look at this, the way it works is if we click on edit, it's going to allow us to edit. And then here's your Azure demo. This is going to point to your Git repo. And then this is the button here where you can do continuous deployment. So if you click on this and you select enable, well, then you have a few options. And then once you click save, then anytime that Visual Studio project changes, when it updates the Git, it's going to initiate a push. So that's how that works. And then if we were to look at the stage, again, we use the agent job, which is pretty generic. And then we have this ARM deployment. So if you remember, this is an ARM deployment here because the JSON file, that's what it is. It's an ARM deployment. It's an ARM template. So what we did was we pointed, one key thing to remember is you need a service principal. A service principal is basically like a generic user that this application can use, and it can reference all the objects. Sometimes there's difficulty in setting up the SP, granting permissions and stuff, but once you have that, you're in pretty good shape. And then we specify the subscription. As you know, in Azure, we have subscriptions and resource groups. In this case, we have a resource group, and then you specify where you want it to be deployed to, and then you link the artifact, and then essentially you go in there and you click on this. So what we see here is the actual Azure Git. So we're actually looking at the Git project, and within the project we have these, we have all this stuff. But in this case, you'll see that those ARM templates are available for selection. And what you do is you select on the main one, and then for the other one you select on the parameters. And the third one, when you click on it, you can actually change the parameters in real time, right? So isn't that cool? So you could actually change it and point it to East US 2 or what have you. So when the code gets changed, it initiates the trigger. The trigger calls this release pipeline. The release pipeline is attached to the Git. The Git is attached to the project, and the project has these parameters, and you can modify the parameters with each deployment. Or, you know, if it's automatic, then what have you. But anyway, that's how that works. So going back here, it looks like the DAC pack had finished, and if you wanted to take a look at the thing, you click here, and then like I said, it has a whole slew of audit trail. So if we wanted to look at what just happened, well, this is what just happened. So hopefully you memorize this because there'll be a quiz. But essentially, you know, we click on this, and if there were any errors, they'd be kind of in here somewhere, and the errors are kind of cryptic in some, so you got to do some Google search. But essentially, it just ran. So what does that mean? Well, if you remember at the beginning or the middle, we kind of added a table. I think it was called demo test 1. So my guess is if we were to refresh this, well, you see, there's no table here. So if we refresh, we should see demo test 1. I think that was the name. Is that right? Yeah. So there it is, and it should have the one field primary key. Yeah. So that's how easy it is to deploy. And all we did was we saved our project. You know, we created our object, and in this case, you could have done a compare and say, okay, compare against the dev and go get me the changes and apply the changes to my project, and then go ahead and save it to Git. The Git triggers the trigger, and then it automatically pushes, and then here you go, you have this table. Keep in mind though that, you know, for stored procs, for views and such, it's real easy. If you have tables that already have populated data, it could throw into some problems, and there's ways around that, you know, such as, you know, writing scripts, post-deployment scripts to massage the data, which is custom, but that's another topic. So getting back to the Key Vault, we have this infrastructure as code, and then we have, this is another project where I'm actually deploying keys. So this is the way I deployed the keys, and hello world Earth. So if we were to go back to our Azure real quick, Azure, basically our Key Vault, in this case, if we went to the 1, you would see there's a value from our latest and then show secret. So that's how they got populated. So let's go ahead and change that. We'll add Mars. Okay, so then I'll go ahead and build the project, the solution. Go ahead and click save. You'll see that the red is up here because it identified a modification. We'll go ahead and click changes. From here, we can added Mars. And then go ahead and push it, save and push. And I'm not sure if this one's actually set up with the trigger. We'll see here in a minute. Okay, so it just stored our code up into the Azure Git, and then we need to go back to our pipelines, environment, our releases. And then from here, here's our Key Vault secrets. I don't think it actually kicked off because 6/22 is yesterday. So we'll go ahead and basically open up our release. Well, actually, you can create the release from here. You can put a comment and say added Mars, and then create. That'll create a release. And then up here, we can click on our release 4, and hopefully it's queued up, and we'll see what happens. So when we talk about Azure Key Vault, one of the problems I ran into, and this may be useful for some people working in Azure Key Vault, but essentially you cannot delete these. Well, you can, but the way that it's set up now is that these things called soft deletes, which means it's kind of like I was talking about Visual Source Safe earlier, where you can delete something, but you can't destroy it. So same thing here, where you can delete the key, but it's still stored. And if you try to run that infrastructure as code again, it's going to throw an error because it says the key already exists. So you're kind of hosed. So let's go ahead and see if this thing is still running. It should have finished. Oh. Okay, it's still queued for some reason, but that's fine. But what I was going to say is that if we tried to delete this key, you can see there's the current version and 3 others. I'll go ahead and delete it because So there you go. So if I was to deploy that code, infrastructure as a code, it would throw an error. So what we have here is in Azure, we can open up a PowerShell, which is really cool. So there's PowerShell and there's Bash, but I predominantly use the PowerShell. And this is basically like a gateway into the guts of the Azure, right? So it's now connecting, it's creating us. If we were to look at the Azure portal, we would see that there's another item added to our resource group, and it's basically the container, the storage account for that PowerShell, which is kind of cool. Yeah, it's storage account. So it kind of created that on the fly. So we now have our Azure PowerShell. So from our DOS days, we click on CLS for clear the screen. And then let's see, I might have some code here. This code here is going to show you the contents of our key vault. It's like the back doorway. So I just go ahead and enter that. It's just a snippet of code, and it'll say, guess what? There's only one secret. There used to be two. What happened? So if we then show another one, say, well, those are the keys, but I want to see the actual values. I click on this, and this one's going. There's no value, and guess what? It does show Mars. So it looks like our deployment completed. How about that? Yeah, except it failed. Anyway, that's fine. I'll get back to fix it later. But essentially, this PowerShell, the code is no longer, the key has been, it's gone. You can't see it. So just one more thing I want to show is that in this PowerShell, you can, you know, what I did on another production or different environment was I entered this script because I wanted to import the keys pipe delimited. So I created the script and then I import this into Excel, and then I can see all the keys in a nice clean fashion. And then I basically use those to deploy those back to another environment, the brute force way, but it's a nice feature. So because we deleted that key, we'll go ahead and enter this script, and it basically says, show me every key that's in the delete state. So there it is. That's our key 2 that no longer exists. Well, we also have a command to undo the delete. Now, I just want to show something real quick, but in the portal, you can't, out of the box, you don't get these permissions automatically. So the way you have to fix it is you go into access policies, and under here, you have something called recover. If you do not have that selected, you cannot recover it. So that's, I had to add that. So basically, if we go back into our, click on our paste for secret 2, it basically undid the delete. And that's possibly why the thing failed. But anyway, so now if we select on our keys, we should have our key back. So I thought that was kind of cool. Anyway, it's not there. So maybe it takes a minute, I think, to propagate. But essentially, I did want to show that. Okay, so we talked about Git. We talked about the pipelines. We showed the example of the SQL database using the DAC pack. We showed the key vault where it updated the Mars, how easy it is, the connections and such. The last thing I wanted to talk about is kind of this this generator thing. So essentially, this is like a Microsoft site, and like I said, if you're looking for examples, this is the way to go. So you just log in, I believe. Should prompt us. Okay, so then we'll just name demo project 1. And then from here, you know, you select your organization, which is, you should already have the Azure account set up. And then from here, you can choose a template. You can choose this one out of the box, or there's a whole bunch to choose from. So as you can see, these are pre-built projects out of the box, and there's a lot to choose from depending on your needs. Those are general. Then we have some labs, machine learning, Key Vault, Docker. The one thing you'll notice real quick in the Azure is that there's no shortage of third-party integration tools, and it's really staggering when you think about it. And then there's a lot of courses also to get up to speed real quick. I find that the best way for me to learn is to just jump right in with a deadline and learn it as fast as possible. And that means like having it fail 50 times in a row. And then in doing so, you kind of learn what works, what doesn't work, the patterns, the techniques. So that's pretty much the method that I've been using, you know, for the 25 years, 30 years in the career, but that's the way I learn it, through trial and error. So what's nice about this website is that you can just click on something. So let's say we wanted to create a release pipeline. You select the template. Yes. Actually, we just create the project. So what it's going to do is it's going to do a pull request. It's going to bring down the objects of the Git, and it's going to store it in our Git repo. And from there, you can interrogate the contents. You can deploy it, and it's kind of a learning technique. So if you're ever in a bind, you can look around and see if anyone's ever done the same thing that you're trying to do, and use this tool as a debugging tool or a learning tool and stuff like that. So that's basically how it works. Yeah, so having a tool like this is really powerful. It's amazing how much sample source code is available, how many developers are actually doing the same thing that you are. I know when I started out coding, we had a handful of developer friends that we used to code, after work, and trying to even get the source code, like Visual Studio, it's a $3,000 item. How are you going to get a copy of that? So just getting the code and then finding like-minded people that can leverage off of, because back then there was no internet, and you just had to learn it through trial and error. Nowadays, I feel like we're fortunate to have this wealth of information available, on your phone or your computer, and as much time as you have to dedicate it, that's how much you can learn. And there's no shortage of there's a lot of people that need these skills. So I would definitely recommend getting up to speed on some of the stuff. As you know, the technology changes all the time, and once I started looking around at this DevOps, I was real impressed, because this kind of fills a gap that we've had in the IT industry for a long time, and it integrates nicely, and you can actually base your career specifically on DevOps. So I'm real impressed. And so if we look at our repos, but anyway, I didn't plan for this part of the demo. I just wanted to show you that it exists, and that there's a whole bunch of stuff that you can do, and it's with a click of a button. So I know we're at 10 of right now, so I appreciate everyone's time, and hope you got something out of it. So that's all we really have. If I go back to my PowerPoint real quick. So the summary, we talked about why do we even need Azure DevOps, the continuous deployment, the CI/CD. We talked about services, the repos, the pipelines, the infrastructure as code, and then we just did a couple of demos to show you, get you started with the DevOps. So with that said, if you want to discuss further, reach out, and we'll be glad to talk. With that said, Crystal, do we have any questions? And thanks again for attending. We appreciate it.
No problem. Hey, John. Yeah, we do have a few questions here. I don't know if you want me to read them off, if you want to take a look at them.
Okay. Oh, here. Questions.
You find them, and if you hit the little square with the arrow in it, it'll pop out and make it bigger for you too as well.
Why use PowerShell over Bash? It's just preference. I'm from the Microsoft world. I started with DOS when there were no hard drives or mouses or anything. So I'm used to DOS. So PowerShell is like DOS on steroids. So that's why I like PowerShell. It's almost too powerful. You can do everything with it. I just haven't used Bash. So you could use whatever you want, to be honest. And what I found useful is that if you're looking for a code snippet on how do I get the key for the thing or whatever, you can use, you go out on the website, and there's usually an example for both. There's an example for PowerShell, and there's an example for Bash. It just depends. So there's no shortage of information out there. I just prefer to use the PowerShell. Another one, can you roll back a release? Well, I imagine the releases are captured in time incrementally, so I imagine you could deploy a previous successful rollout. That's one option right there. I could see that easily. I haven't had to do that, so I might not be an expert in that question, but I imagine I would just roll it back to a previous iteration that did work. Keep in mind though, typically in Azure, we don't just deploy one resource like, oh, I think I'll update the Azure Data Factory today. there's usually a slew of other changes. There's key vault entries, there's database changes, there's logic apps changes, storage account changes. So changes don't typically happen isolated. They're usually in a bundle. But the nice thing about the resource, the DevOps is that you can bundle them together. Oh, the difference between commit and push. Well, I can do a commit in Git, but other people may not see the changes. Once I do the push, then the push actually moves the code to the cloud. All I know is that if you don't do the push, nobody can see the code. So that's why I do the push. And you can do them separately, or if you do it over and over, you just do them together, commit and push at the same time. It's just preference, I imagine. Trying to read the meeting note. Are there any other questions?
That looks like, let's see, can you know about the release? How do you handle? That looks like the last one, unless anybody is typing any other questions in, but that.
Well, the first one says, do you think there's going to be widespread adoption? And I 1000% say yes. I mean, there's so many benefits to this, and it's just incredible. Like I said, I've been coding for a while now, and we've never had anything like this. Once I started working in this environment, like we can create all these objects in Azure, automated, repeatable. We can move it from, we can move it from environment to environment. We can wrap processes around it. Real quick though, I can show you how do we obtain those ARM templates. Typically, there's an export template here. If you click on it, it'll generate the template in real time and then the parameters, and you can deploy these immediately, or you can save them to your Visual Studio project or code. Some people use Visual Studio Code. That's the latest and greatest. It's a lightweight version. And then you can store those to Git as well. So in any resource that you select, basically you can click on that export template, and there's a good chance it's going to write the code for you, so you don't have to start from scratch. So obviously they've thought it through. It's a great feature. It's customizable, 1000%. So I think if you're not using DevOps, you should probably look into it, because it integrates with the data governance and it helps your team. It streamlines it. It gives you credibility to the client, automated processes. So yeah, I think it's definitely going to take off. So hope that answers the question.
I think you got a couple of more that just came in. One that's asking, can pipelines be used to deploy code to hybrid environments or to premise only environments?
I haven't messed with that too much, but I imagine, there are so many extensions built into the pipelines, and especially, with the ability to deploy to Kubernetes on the AWS possibly. I haven't looked into it, but I imagine if you can deploy to Kubernetes, I'm probably not saying the name right, but I imagine you could deploy to other clouds, I imagine. Don't quote me, but I imagine. And as far as on-premise, I haven't done that before. We've done hybrid projects where we're pulling data from the on-prem to the cloud. So I've never had a use case for that, but I'd have to research it.
Okay, and the last question you have here looks like it is, I'm assuming this is the same question. Can pipelines be used to deploy code to hybrid environments or to on-premise only environments? Yes, I believe that is the same question. All right, yeah. That looks like the last one. John, I want to thank you so much for hosting this webinar. It's been great. Sorry, I got one more that just came in. Is the Git repository private or public?
You have the option. You can do both. In our case, it's proprietary code, and the client owns the majority of the code. It's private, but you could deploy a public one as well. Yes, to answer that. Both.
All right. All right, I'm going to give a few more seconds here to just make sure no one else has any questions. All righty. All right, John, well, thank you so much for hosting. Like I said before, thank you. We really appreciate it. Everybody else, I hope you guys have a great, wonderful rest of your Tuesday. I also wanted to let you guys know, I know some people were asking about the recording. You guys will receive the recording tomorrow around noon or 1 p.m. Eastern Standard Time, so look out for that. If you guys think of any questions after that or before that, please feel free to reach out to John or myself. We are definitely here to help you guys. Like I said before, John, thank you again for hosting, and I hope you guys have a good rest of your Tuesday.
Thanks, everyone. I appreciate your time. Have a great day.
Thank you.
Bye.